Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about Pythagorean Theorem. Pythagorean Theorem is basically a formula. So the formula a squared plus b squared equals c squared. And it can be used to find the missing side of a right triangle when given two sides. Okay, so a couple things you got to note in there. It has to be a right triangle in order for this to work, and you have to be given at least two of the sides. So C must be the hypotenuse. So whatever you put here has to be the side opposite the right angle. Okay, and I've noted that here. So if the right angle was here, it has to be this side opposite. That is always the hypotenuse. Okay, so C has to be the hypotenuse. A and B are just the legs. And so it doesn't matter which one I label A and B. This could be A, this could be B, this could be B, this could be A. Okay, legs are interchangeable, but the hypotenuse must be C. Okay, so let's look at some examples. Here I've got a right triangle. I notice that the hypotenuse is X. Okay, so X has to be in the place of C. Now I'm going to make A 3. And I'm going to make, and I'll note that on here, I'm going to make A3, I'm going to make 4B, and then I'm going to make XC, okay? So if I were to write this out, so it would be A squared, in this case 3 squared, plus B squared, 4 squared, gives me C squared. Now that one is our X. So that's what I'm looking for. I'm solving for X. Now here I can simplify this on a calculator real easy. I could do them individually, 3 squared and then 4 squared, or I always like to save time just by plugging it in. 3 squared plus 4 squared. Okay, and that gives me 25. So I've got 25 equals x squared. Now remember, they don't want to know x squared, they want to know x. So I've got to think, how could I get rid of that little 2 right there? Well, hopefully you're thinking take the square root. Okay, take the square root gets rid of that little 2. But I can't only do that to one side. What I do to one side, I have to do to the other, right? So what is the square root of 25? Well, let's check. I know it's a perfect square, just because I know, but let's double check. So it is 5. Okay, so 5 equals x, because I got rid of that little 2. Okay, so now I can say what C is. C is 5. So by knowing two sides, I was able to figure out the third side. Let's look at this example over here. Again, I have a right triangle. I know two sides. I need to know a third side. Now remember, the hypotenuse must be C. Okay, so this time my x is not going to be my C. My 41 will be the C. So I can set that up as, I'm going to call A this 9, the x I'm going to call B, and then the hypotenuse, as always, will be C. So here we go. A squared, 9 squared, plus B squared, that's the one I'm solving for, x squared, equals C squared, 41 squared. So now I'm going to have to do a little more solving than I had to do over here. 9 squared, so that's 9 times 9, which is 81, plus x squared equals 41 squared. I definitely need a calculator for that one. Should be 1681. 1681. Okay, now I do want to get my constants together. I want to leave my x squared alone. I want to get it alone. So I'm going to subtract 81. Okay, now I get x squared equals 1681 minus 81. Well, that would leave me with just 1600. Right? So I've got 1600 equals x squared, but I don't want to know x squared. I want to know x. So I've got to undo that little 2 by taking the square root. Okay, that cancels that little 2 out. All I have left will just be x, but I can't just do that to one side. I have to do it to both. So I've got to think, what is the square root of 1600? Well, let's try it. Square root of 1600? 40. It came out to a nice perfect square. So x equals 40. So I can now say what b is. Let's look at some word problem examples. So this first one says a ladder is 12 feet tall and is leaned against a house. If the bottom of the ladder is placed 5 feet from the base of the house, how high will the ladder reach on the side of the house? Okay, so anytime you have a problem like this, the information can be overwhelming, okay? I always say stop and draw a picture. It'll really help you visualize it instead of trying to do it in your head. So I know I've got this ladder and he's leaning against a house, right? So let's draw the ladder, and that is leaning against a house. That is a terrible house. You'll have to forgive my non-artistic skills, okay? Now, how tall is the ladder? It tells us that the ladder itself is 12 feet tall, okay? Now, here's going to be our right triangle, all right? And then we've got our ground right here. I should note that. Okay, so our right triangle will be the house and the ground. Okay, now it says the bottom of the ladder is placed 5 feet from the base of the house. Well, the bottom of the ladder would be here. So from here to the base of the house is 5 feet. Now it asks us how high will the ladder reach on the side of the house? So that's going to be right here. How tall does this ladder, how high up the house is this ladder? We're going to call that our X. So hopefully you can see through my very elementary drawing that we've created a right triangle here, and we know two sides, right? We know the hypotenuse and we know the base, one leg, but we need to know the other leg. So let's go ahead and write our equation. So remember that it's a squared, one of the legs, plus b squared, the other leg, equals c squared, the hypotenuse. So let's go ahead and put the c in. The c I know is 12. And I know that because it's opposite the right angle. It's the longest side. And then a squared, I don't know, I'll call the 5a and I'll call the x b. You could have done the reverse. You should get the same answer. So 5 squared plus b squared. And we're solving for b, and I called it x over here and b here. It really doesn't matter. We're solving for that side. You could call it b squared, you could call it x squared, doesn't make a difference. Okay, so let's go ahead and simplify this. So I know 5 squared is 25, right? I don't know anything about b squared yet. And then 12 squared, I believe, 144. All right, now I want to get my constants all to one side. So we want to subtract 25. 144 minus 25, that's going to give me 119. So I've got b squared equals 119. But remember, I don't want to know b squared. I want to know just b. So I need to take the square root to make that little 2 go away. If I do that to one side, I have to do it to the other. So let's see if I can get the square root of 119. Let's see if it's a perfect square. And look, it's not a perfect square. Okay, so some teachers in certain situations are going to say, hey, the decimal's fine. Just put that it's 10.9, okay, or 10.91. But sometimes your teachers are going to say, no, you can't have a decimal answer. You have to have a simplified radical. So in that case, we would need to see if we could simplify square root of 119. In this case, they did not specify how they wanted our answers to be listed. So I would do both, honestly. So I would say we know it could be 10.91, but let's also see if 119 breaks down any further. Off the top of my head, I don't know anything that goes into 119. So let me come here to my y equals, and I'm going to use that calculator trick. We've used this throughout my videos. 119 divided by x. When I go to my second graph, this is my table, and it's going to pull up everything that goes into 119. Now, I see that 7 and 17 would go into 119. Let me see if there's anything else. Well, and then here's 17 and 7, and once I get a repeat like that, I know I've seen everything. So let's see if we can break down 7 and 17. Well, if I took 119, and I broke it down into 7 and 17, notice these are both dead ends. So this goes back into our simplifying radicals video. So if you're not sure what I'm doing right here and you're confused, stop here, go back and review the simplifying radicals video, so this will make a lot more sense, okay? Now notice I have all dead ends here. 17 can't break down any further, 7 can't break down any further, so that means 119 is as low as that simplified radical, it's as simplified as the radical is going to get, okay? So I would say B equals, you could say either square root of 119, if your teacher wanted a simplified radical answer, or, and then let's go back to, I'll pull back up here, what we found the decimal would be 10.91. Now personally, I definitely prefer the decimal answer because to me it makes a whole lot more sense to say, okay, well, the ladder reaches from the bottom of the ground to 10.91, almost 11 feet up to the house. To me, that makes a lot more sense than saying it reaches the square root of 119 up to the house. Even though those are the same number, I prefer decimal, but sometimes teachers will ask for the simplified radical. So you want to be prepared to give them both. So our next example says, what is the height of the triangle below? Give your answer in a simplified radical form. So notice here, they were very specific. They want that simplified radical. So looking at my picture, okay, I've got a large triangle here. I know that from here to here is 2, from here to here is 7, and then I can see the height. It's kind of like this dashed cut line down the middle. That's h. So that's what I'm solving for. So notice how if I were to just cut that side off, right? I've got two sides here, and I need to figure out the third side. Now you may be saying, well, that side looks weird. 3 square root of 6, that's weird. It is a measurement of the side. I could put it in my calculator and get the decimal version, okay? But I know two sides. I need to know the third side. So Pythagorean theorem is definitely going to be the easiest way to help me here. So I would take, now I want to know what is my a squared and what is my b and what is my c. Well, my right triangle would be right here, right? So that means 3 square root of 6 is my hypotenuse. So that's got to be the c. So let's make 2a and h, we could label it b, or we could just continue to call it h. That's what I'm going to do. So we've got a squared, which is our 2 squared, plus our b, which is, we're going to call it h squared, equals the hypotenuse c, 3 times square root of 6 squared. Now, that confuses a lot of people. They say, how do I do that? Well, all you do is 3 square root of 6, put parentheses around it, and square it. Okay, it's a lot less, it looks complicated, it's really not. Just put parentheses around it and square it. Okay, now let's do some simplifying. 2 squared is 4, right? Still have this plus h squared equals. Now, you may be thinking, how in the world do I simplify that? We're going to put it in the calculator exactly as it's written. And I say exactly because it can be easy to mess it up. Okay, so we're going to do a parenthesis, 3, square root of 6, second square 6. Now here's where it gets tricky. I have to come out of that radical. See how that radical is extended? I have to hit the right button to end the radical. And then I have to do my second parentheses. And then I will square that. Okay, so notice how this looks just like this. If it looks a little kooky, you've probably done something wrong and it's not going to give you the answer that you're wanting. So just be careful. All right, so when I simplify that, I get a nice whole number, 54. You'll be surprised how often that happens when your teachers build these problems. Usually they want to be nice. So this does simplify to a whole number. Won't always, but here it did. Okay, so let's get our constants together. Subtract 4 from both sides. Now we have h squared equals 54 minus 4 would be 50. So I know h squared, but that's not what I want to know. I want to know h. So I've got to take the square root to get rid of the little 2. And if I do that to one side, of course, I have to do it to the other. Now, let me just see, so I'll have h equals, let me just see if 50 is a perfect square. Let's just see. It's always good to test, right? And it's not. When you get a long decimal like that, you know it's not a perfect square. So some teachers may be okay with you leaving it as a decimal, but here they have specifically told us simplified radical form. So I'm going to have to break 50 down. So let's think. What are 2 things that go into 50? I would say 5 and 10, right? Those aren't the only 2 things, but they're the first things that come to my mind. 5 is a dead end. I can't break that down anymore. 10, I can break down to 5 and 2, right? Remember, if it's a square, we are looking for pairs. We are looking for sets of 2. So if I can circle the 5s, that means that is 1 5 that I get to bring out. Okay, and then the 2, he didn't have a partner, so I box him. He has to stay underneath the radical. Okay, so that's going to be my final answer. The h is 5 times square root of 2. Now, I could put in my calculator and just see approximately how much that is, just for good reference. 5 square root of 2 is 7.07, so whatever measurements these are, whether it's 2 feet or 2 inches, this would be 7.1 inches or feet. So good to know. A diagonal that cuts across a square is 10 feet. How long is each side? Give your answer as both a decimal and a simplified radical. Remember, we've got to be able to do both consistently. So let's visually see this. Let's draw a square. So I've got a square here. Right? And it says that I have a diagonal that's cutting across the square. And that diagonal is 10 feet. Okay. Now, it wants to know how long is each side. So you may be thinking, well, I know that to use Pythagorean Theorem, I have to know at least 2 sides, right? But the fact that this is a square tells us that all sides will be the same length. Okay, that's the definition of a square. All sides are equal to each other. So I can really say I can call this A and I can call this B, but I know A and B are going to be equal to each other. So some people might choose to do, right, and this is honestly what I would do, I would label this side X and this side X. I know they're both X. They're equal to each other. They are the same. Okay, so I know that I've created, and I kind of did this without really stating it, but I've created a right triangle here. By cutting that diagonal across, I can really blank out that top triangle and just focus on this bottom triangle. And because it is a square, this is a right angle, which means it is 90 degrees, okay? And of course, we have to have a right angle, a right triangle, in order for us to be able to use Pythagorean Theorem. Okay, so I know this side is x, this side is x, that side's 10. The hypotenuse is 10. So let's write that equation. X squared plus x squared gives me the hypotenuse 10 squared. So let's just simplify this. X squared plus x squared, that is 2x squared, right, equals 10 squared, so 10 times 10 is 100. Okay, now I want to divide both sides by 2. So that just leaves me with x squared equals 100 divided by 2 is 50. And of course, I don't want x squared, I want x. So that means I got to take the square root of both sides. So I have x equals, now it just so happens that this one happened to be square root of 50, which is the same as our previous example. Not intentional, just coincidental. Let's see, I already know 50 is not a perfect square, right? Because we just did it on the last one, but just as a quick review, we can break it down, right? I'll break it down differently this time. So last time we did 5 and 10, this time let's do 25 and 2. And you'll see that we get the same answer. So for the 25, we could break that further into 5 and 5, right? And we still end up with a pair of 5s. and 1 2 with no partner. So those 5s come out to make 1 5, and then the 2 stays underneath the radical. Now we do need to be able to write this in a decimal form as well, as that's what it asked us to do, so we'll note that. So 5 times the square root of 2, and that would be 7.07, or you could say 7.1, so we'll note that. Or 7.1 feet, right? Because our measurement was in feet. Okay, here's one for you guys to try. So this one says a flagpole is 20 feet high with a rope secured to the ground 15 feet from the base of the pole. How long is the rope? Okay, so I definitely recommend that you draw a picture with this one, just like we did the one with the ladder, that you draw a flagpole, draw the rope secured to the ground, okay, and label each part that they have given to you. I will post the answer in the video description below. This has been Miss Smith's Math Tutorials.